Hello, my name is Miloš Dimčić and this is a course on programming in architecture. More specifically on how to write plugins for Rhinoceros 3D in C#. So you can check out my other courses because I will release more of them in time, and depending on when you're watching this, they already may be out. Even though the words architect and architecture are prevalent throughout our videos and lessons, they're definitely not limited to architect. This course is for everyone that uses computer-aided design to create geometry, and that encompasses also product designers, jewelers on one side, and civil and mechanical engineers on the other side. Whenever you deal with complex geometry and it is too complicated to handle it with standard tools that came with your software, then you will want to write your own methods in order to generate, optimize, and fabricate your models. I firmly believe that being able to have this type of control over your project will shift us into the new era of efficient, sustainable, and much more imaginative buildings. Now, do you need programming knowledge? No. I imagined this course and created it so I can take you on a journey from the absolute beginner when it comes to coding to the expert. And I thought about what the best method will be, and I decided that for every programming language I will make a separate course. So you will also have access to a basic C# course that I made. And this course will not be as comprehensive as a standalone C# course. It will be tailored to fit with our programming courses and in combination with software that we use and teach, like Rhino and some others like Unreal and Revit. If you're a total beginner, you have two options. If you're confident in yourself and you know at least something about programming, start immediately with this course and from time to time watch my C# Basics course in parallel when you do not understand something or need clarification. And I will always refer to a specific video in the C# course whenever I bring something up that is explained there. If you're not so confident and you want to take it really slow, then first watch the complete C# Basics course, and later you can return to it whenever you need to repeat something you forgot. I distinguish between two types of courses, one that tries to get you from zero to some product. Imagine if I told you in this course we will generate a complete skyscraper with a facade and structure all automatically. Those courses are very attractive because you have something to show after you're done. But in my experience in those courses, people very often skip a lot of important stuff because otherwise the course would be too long. So instead I decided to make a foundations online course, the one that will not give you a flashy result, but will cover all the fundamental aspects of programming for Rhino so that you can create whatever you want. Here's how I see it. I will create courses for different software as well, and we will progress slowly from level 1 over higher levels, trying to cover everything that is relevant and needed. And from time to time I will make those example-based courses that in my mind look like this. They cover some areas from the beginner's level, some from the higher level, but at the same time skip a lot. So I'm starting with foundation courses like the one here, and if you think you do not want to learn programming in that way, then you can check what else I have in stock. That being said, that does not mean we will not have exercises here. No, far from that. We will select geometry, create geometry, even do some facade paneling. Just nothing flashy. All exercises will be designed to make you learn basic aspects and skip nothing, so that tomorrow when you want to write your own code, you know how. So what will you be able to do? You will be able to write your own plugins with your own commands and dialogues. You will be able to use your skills to automatically generate geometry, optimize geometry, prepare it for static analysis or production, etc. By learning C#, you will be able to do much more than one can do with visual programming like Grasshopper or scripting like Python. And your algorithms will work much faster than using any of those methods. Not faster and not more efficient than C++, but the programming itself will be fairly simpler than the one in C++. If you're interested in what programming language to choose, watch this video where I talk about the basic difference. Now, who am I and what did I do? Why should you learn this from me? Well, without false modesty, I belong to the relatively small group of people in the world that has relatively large experience in parametric or computational design. Not theoretical, but actually practical and applied. I finished the Faculty of Architecture, specializing in structural system and static analysis. I did my PhD in Stuttgart, Germany, one of the best places in the world to study structural design and lightweight structures in the world. Now, during my studies, I worked for the Knippers Helbig office in Stuttgart, and in 2011 I founded Programming Architecture and have been doing programming for architects, structural engineers and building companies since 2007. Now, I worked on some of the largest and most complex objects in the world, and for many of them single-handedly automated the generation of all facade and structural elements, optimized geometry, did structural optimization, prepared tens of thousands of elements for production, etc. I will not go into detail here, but you can check the projects on our website and see all the projects I worked on and what we did for them. In my work, I combined CAD, FM, CNC production, and eventually combine virtual reality and artificial intelligence algorithms. Just check all the links I provided if you want to find more about all my activities. Now, why should you use Rhino? At the moment of making these videos, Rhino is the most efficient program for handling complex geometry in product design and architecture. As I mentioned, I worked on some of the largest and most complex projects in the world, and I can confirm that Rhino was used for all of them as a main tool for the generation of geometry. Now, there is a video in the description where I talk about that as well. And I'm also an authorized Rhino trainer, and you can check our offers for Rhino courses if they're out. Of course, architectural projects usually imply a combination of different software. For example, often we have to deliver the project in a BIM software like Revit. We have to prepare our geometry for static analysis and export it to different FEM software. And all this is much easier to do if you're able to program your own routines. We will cover all of these things in the courses. Now, why should you learn how to program at all? Well, programming is the future. If you do not live in a cave somewhere, you're probably aware that everything around you is being automated. Now, what does it mean automated? That means that someone thought of an algorithm and wrote a code that computers and machines execute. As they cover more and more of our work, we as a species will have to learn how to write code, because those will be the only things to do when the machines take over most of our work. Yes, the machines are already taking over programming as well, but we have a little bit more time there and we should use it. Now, I do not want to use the term job because I hate it and because I believe that in the near future a classical job will not exist, but for the sake of making the point, programming will be one of the more important jobs even in architecture and design. Sustainable, fast, cheap, and above all, cool design solutions are almost always custom made. Imagine your car. It gets more and more complex, hardware and software-wise, but it gets more efficient and more comfortable, faster, and eventually drives on its own. The same metaphor can be applied to the building industry. By using complex algorithms and methods, we can make our buildings and our products smarter, cheaper, more efficient, and sustainable. Why not just use Grasshopper? Hey, Grasshopper is amazing, but it depends on what you want to do with it. Let me go through a couple of points. If you know how to program in C#, you will be able to do more than what you can now in Grasshopper. Whatever you program in C#, especially if you do something in an iterative manner, something that works in loops like optimization algorithms, that will work faster than in Grasshopper, because whatever you do in Grasshopper, it has to be translated before it gets executed. And then the complexity grows exponentially very quickly. When you program in C# and use an IDE like Visual Studio, you can organize your code in different files, classes, functions, and have a nice overview. Visual programming can get very confusing with anything that is fairly complex. And with Grasshopper, you cannot really make an actual plugin, although there are some tools out there right now, but something that is neatly packed and works on its own, the best route is C#. And eventually you can use C# to create your own plugins and components for Grasshopper as well, if you want to. And why C#? Well, my original language of choice was C++. When I learned it, I needed to write very complex and computing-intensive optimization algorithms. There I had a large control of the code, and because it's a low-level language, it is one of the fastest. But the downside is that it's much more complicated than other languages, and you have to handle your memory, write generally much more code than in C# or Python to do the same operations. And if you're interested in speed, first and foremost, then C++ might be a slightly better choice. However, C# is not so far behind when it comes to speed, and it comes with many other advantages. If you care about your code being more reusable, portable, scalable, ready for different platforms, then C# is the better choice. C# is a part of a larger platform called .NET, and this platform or framework was designed by Microsoft in order to make your code be easily integrated with other software, to make your code be cross-platform, to work in different operating systems and different devices, and to be able to combine different programming languages like C#, Visual Basic, and some others. Now, anyone can learn how to program. You really do not need to be extra smart to learn how to program. You only need to want it. A good teacher, and I hope I will prove to be a good one, can explain programming in relatively simple terms. You just need to compartmentalize the material I'm offering to you and not jump and skip anything that's not clear. If you do this, if you follow the basic structure step by step, everything will be logical and rational. After all, whenever I think something is complicated and I do not understand it, I remember a simple fact. Computers can only work if you reduce everything to the simplest, binary form, 0 and 1. Every code ever written can be traced down until it breaks into zeros and ones, true and false. And that means that everything that looks confusing has a simple and logical explanation down the hill somewhere. You just need to be patient. Now you can try and then buy. The first couple of videos will explain what software to install and how to set up and build your first plugin. Those lessons are free and I urge you to go through them before you buy the course. The reason is that there are unforeseeable reasons, hardware or software based, that will maybe prevent you from overcoming this initial step. This will rarely happen and I can help you solve the problem, but in order to avoid a stupid situation in which you bought the course but cannot even start, go through the first 3 lessons, set up your first plugin, and if that works, the road is wide open in front of you and we can start our journey into the adventurous and exciting world of programming. And eventually the clock is ticking and we are all changing. The younger me has made this course some years ago and I will let him guide you through most of it. Whenever there is a need for me, an older me, to jump in with an update because some tools work differently nowadays, I will do that. In that way you will have the course that is current and updated. You just have to accept to be taught by 2 or more people, or 1 person from different times. So let's continue. If you want to write code in C# for Rhino, we will use something that is called Rhino Common. I told you that C# belongs to a so-called .NET platform, and Rhino Common is an SDK, software development kit, that will enable you to write your own plugins for Rhino. The great thing about Rhino Common is that it is cross-platform. It is used to write code for Rhino for Windows, Rhino for Mac, to write for Grasshopper, create your own components, for example, and for Rhino Python scripting as well. The Python scripting engine is entirely based on Rhino Common, and all Python scripts use Rhino Common to work with Rhino. In this course, we will only cover Rhino for Windows. Depending on the time you're watching this, I may have released other lessons on working with Rhino Common, but as I said, in this one, we will be using Rhino Windows. That being said, a big advantage of working with Rhino Common compared to Rhino C++ SDK, for example, is that your plugin could potentially work on Windows and Mac without any changes. What does potentially mean? Well, we'll talk about that later on, but if you enter this course, you should not plan on making your plugins that will definitely work on a Mac. Just potentially. For a plugin that will definitely work on a Mac, I will probably make another course and you should check it if it's already out. Hi, sorry to interrupt the younger Miloš, but as this course matures, I do as well. So the older and more experienced me will intervene from time to give you the updates. The original course was made for Rhino 6, but now I updated it to work with Rhino 7 and Rhino Work in Progress, which will soon be Rhino 8. If you still see Rhino 6 in some parts of the course, I left it there because nothing has changed except for the number. The course will be of course updated for subsequent releases of Rhino. If you're watching this video in year 2050 and you're still working with Rhino, kudos for Rhino. We will develop for Rhino in C#, in Windows, and with the help of another Microsoft software, Visual Studio. Visual Studio is also called IDE, Integrated Development Environment, or in plain English, software used to write your code. In most of the course, I use Visual Studio 2017. And at the moment of creating this update in 23, I'm using Visual Studio 2022. Now there is really no difference between the two that matters for this course. But if there is some, this older me will jump in and update the younger me. Visual Studio has of course a free version called Community next to the Professional and Enterprise, and you will find the needed links below. And all 3 versions will work, and the good news is that Community version is free for students, open source contributors and small teams. I will keep you up to date, of course, and add new information whenever something new appears. Once you have Rhino and Visual Studio that you need, we can start with the lessons.